Uh-oh.
Alright, so we're RMG and we did Calvin 3.0, which is the name of our robot. I'm Jordan, and I was I'm Igor.
Jason.
Jason. I was the lead designer on the robot, and I helped with most of the structural designs for the robot.
I did the programming. I just kind of threw in random what if ideas.
I was also a designer and I helped with the program.
I took care of the journal and kind of kept them in line.
Okay, so the objectives for this robot was the use of all four sensors. We wanted the robot to be able to turn, so that was one of the first problems we talked about. It has trunk storage capacity that's very high compared to Honda or Toyota, and we wanted to have a pre-designed course for the robot to go play on. So we finished all of those goals. Our first problem was being able to make the robot turn, because when you had the first robot, if you see in the bottom picture, we put the weight on the back wheel, and so all of the weight was not on the motors, and so the robot had a really hard time going anywhere. And then we came up with, it should be on the next slide, is the idea of putting this turning wheel on, but we still had the weight on the back. I don't know why we didn't move that to the front earlier. But then we came up with the idea to move the weight onto the front of where the motors were, and it got all the traction it needed. And the rotating wheel, we used the turret that was normally like the Rubik's Cube project, used it for the turning of the Rubik's Cube. We used it for the turning wheel, and that was actually our what if guy's idea. And this was the final construction of the robot. We tried to have everything in the middle and just as balanced as we could, so that we didn't have any problems with stuff being out to the side or anything, and everything worked out very well.
So for the programming, we first wanted to have it follow a line, a black line, and then on a clap to have it start moving forward until it's pressed by the touch sensor, and then start moving back, and then the ultrasonic sensor to sensor how far away it is from the wall, and then when it reaches a certain point, I don't remember how far probably to reach, and then it starts churning, and then when you clap, it stops.
We've tested it like 10 times now, and it works every time now. And like we said, the biggest challenges were having it follow the line and also the turning, getting that dialed down, because one of our biggest problems was the motors were too sensitive, and so when it would lose the line, it would spin really quick, and so it wouldn't be able to catch that line again and keep going. So that was one of our biggest problems. And it also has points for defense, because I was hoping we were going to do battle robots.
Okay, any question? Okay, let's see their robot.
Calibrate, know what white is and what black is. Just put it over white. Just put it over the black line. Just the black line. Now if we start it just to the left of the black line, it should turn right until it finds the black line. And it should follow it. Now here it'll lose the black line again. And it'll just turn right until it finds it. And now that it lost it, it'll just keep turning right until it finds it again.
And like I said, one of the biggest problems was it was turning so quick that it couldn't catch the line.
So again, now if we clap, it'll just go straight. So it hits the line sensor. It'll go back until it hits the ultrasonic. It'll spin in circles until you clap again.
Or it runs out of
It hit
program line.
Well, no, it hit the little thing. It stopped it.
Oh, it hit that.
Just waiting for the sound to stop it.
Okay, any question?